So as we know that till now we have been seeing body is traveling in a straight line. Is it yes or no? So when the body is traveling in a straight line, so we have studied that what is the speed of the body, what is the velocity of the body, what is the acceleration of the body, understanding what is the deacceleration of the body. This is all we studied for a body which is traveling in a straight line. Is it yes or no, guys? Either it is moving upward or it is moving horizontally or vertically, whatever it is. So all the properties of the body, the motion in one dimension, clearly we studied till now. Now, if it comes to here, today's class, we'll see if the same body when it is traveling in a circular motion or a circular path, then what is the properties of body, the same like a speed of the body and as well as velocity of the body and as well as acceleration of the body. Do you understand everyone what I'm saying? So now what will happen, how to calculate them, what will be present, that is all we'll understand now. So if it comes to now, first of all, circular motion. So what do you mean by circular motion? Anyone? When a body moves in a understand, when an object will move in a circle, then we can say it is in circular motion. Do you understanding? So motion in a circle, if you want to say simply, if any body is moving in a circle, a body moves in a circle, moves in any circle, then that is what we used to call it as circular motion. Is it yes or no? So that is what you have to remember. So before we studied uniform circular motion, first of all we'll discuss what is circular path, and later we'll consider how it is made up of infinite of tiny sides of any body moving along such a circular path changes its direction of motion continuously. Now, if you'll observe very carefully in our textbook also, if you're having page number 36, all of you open. So if we'll take for example, square. Square is having how many sides, guys? Square is having how many sides? 4 sides. Is it yes or no? Please respond. Square is having how many sides? Square track, 4 sides. If we'll take hexagonal, hexa means what? 6. If you're having hexagonal side, then it will be having how many sides, guys? How many sides? 6 sides. Understand? So now, same way if we take octagonal track. Octagonal means how many sides, guys? Octagonal means it will be having 8 sides. Understand? So octagonal means it will be having 8 sides, it will be there. So you can notice it. So similar way, if we'll take circle, so infinite number of sides will be there. So each circle if we'll take, it will be added by millions of parts. Is it yes or no, Harish? Ready? So thousands of parts, if you keep on increasing the number of sides. Understanding? 4 sides, 5 sides, 6 sides, 7 sides, 8, 9, 10, 11, 12, 13, 14, 15, so on. Then finally, the shape is continuously turns into what? Finally, it will turns into what, guys? It will turns into circular path. Is it yes or no, guys? Please respond. So if you keep on increasing the number of sides, then the shape of the body will turns into what, guys? Will be turns into circular track. So the infinite number of sides, if will keep on increasing, then it will leads to the circle. Now, if you tell me, if the body is traveling in the square track, how many times the direction will change, guys? How many times the direction will change? 4 times. Yes or no? If the body is traveling in a hexagon, how many times the direction will change, Harish? How many times? If the same body is traveling in the octagonal structure, how many times the body will change direction? 8 times. So, if the body is traveling in a circular path, how many times it will change the direction? Infinite number of times. Understanding? Because we don't know each and every point, the direction is keep on changes. That is what we used to call it as circular path. So, how to get the circular path? By adding infinite number of sides. Understanding? So by adding infinite number of sides, then the shape of the body will be keep on turning into while running along the square track. We can take 4 sides. Then you can take if the same, if you are running the hexagonal tracks, then 6 sides, 6 times your direction will change. Then octagonal one, 8 times. Then if you take Understanding? So then what is happening? If you're running the octagonal track, we have to change 8 sides, so that athlete has to change its direction of motion 8 times. So if the body is entering into the circular path, then what will happen, guys? The direction of any person running in this path keep on changes. Once it will become circle or it will become circular track, then the person who is running in the circular track, his direction of motion changes continuously. Is it yes or no, guys? Please respond. So that is what. So when the body moves along the circular path, then its direction of motion keep on changing is continuously. So if the direction is keep on changes, somebody will change. What is that, Arun Kailash? If the direction is keep on changes, then something will changes. Even though, for example, let me take Arun Kailash is running with a 30 kilometer per hour. What is this called as? 30 kilometer per hour. What was to call? It is called as speed of the body. So continuously in the path, the Arun Kailash is running with the same speed. So speed is a vector quantity or scalar quantity? Speed is a scalar quantity. Others don't know. You have to speak correct. Danishkar, what I told you yesterday itself. Leave from the meeting if you are not speaking. No worry. I will say to your father. Okay, that is what. So scalar quantity. So if you take the speed does not having no direction, or direction will never be mentioned. That is why it is called as scalar quantity. So Arun Kailash can run across the circular path with the same speed, but is it the velocity same? Is it the velocity is same? Velocity is not same. Why? So if you take, for example, here the body is traveling. So what is the velocity, guys? Velocity 30 kilometer per hour towards to which direction? East direction. Yes or no? When the body is running here, then here what is the velocity? 30 kilometer per hour towards to the south. When here 30 kilometer per hour towards to the west. When here 30 kilometer per hour towards the north. Is it all the directions are same? Yes, please respond. No. So when the direction is changing, then we can say velocity also keep on changes. You can notice it. So at every point when the body is traveling in circular path or circular track, each and every point, the direction of body will changes. If direction is changes, then who will change? Velocity also changes. Is it understand, everyone? So when the body is keep on moving in circular path, who is remains constant? Speed maybe remains constant, but what about the velocity, guys? Speed maybe remains constant, but what about velocity? Velocity is keep on changes. So that is what we used to call it as circular motion. When a body moves in a circular path with a uniform speed or constant speed, then we can say its motion is called uniform circular motion. Understand? So now what is Arun Kailash speed? As I said here, 30 kilometer per hour. So continuously if he is moving with the same speed, then we can say he is in uniform speed or non-uniform speed. He is in uniform circular motion. Do you understanding, everybody? So he is in uniform circular motion. When we can say when the body is traveling with a uniform speed, or also we can call it as what? Constant speed. So same speed we can say. When any body is traveling with a uniform speed or constant speed in a circular path, then we can say that motion is called as what? Array? Uniform circular motion. Okay. So if you take this uniform circular motion, maybe uniform speed as long as the traveling equal distances in equal interval of time, but velocity of the body is not constant. Why, guys? Velocity is not at all same. Velocity of the moving body in a circle is not uniform. Why? Please respond. Yes, please. Others? Because why? Maybe it is uniform speed, but not uniform velocity. Why? Because the direction of motion is continuously changing or constantly changing. So that is why it is velocity is not uniform, but speed is uniform. Is it okay, guys? Yes. Now, you tell me, if the body is in circular motion, is it the body is continuously accelerating or not? That is what I want to know. Anybody? Yes, please. Is
Sir,
it
in the uniform circular
if
motion, sir.
body is in acceleration or not? If it is body is in uniform speed, if the body is traveling in a circular path, as we know, constant speed or uniform speed, but velocity is not same. Understanding? Velocity continuously will change. Now you tell me, if acceleration is a parameter which is based upon velocity or speed?
Velocity, sir.
Velocity. So now, if the velocities keep on changes, then rate of change of velocity, what we used to call? Rate of change of velocity is called as acceleration. Yes, Danishkar, Arun Kailas, no response at all. If not interested, leave from the meeting. I don't have any force. So, if the velocity of the bodies keep on changes, then who will change, guys? Acceleration also is keep on changes. So, we can say a body is in circular motion. Is it accelerating body or not accelerating body? It is the accelerating body continuously. Why? When the velocities keep on changes, then the bodies also keep on changing its acceleration. That is why any body which is in circular motion, we can say it is accelerating motion, accelerating body. Do you understand, everyone? Are you understanding? The body is in acceleration. That is what you have to remember. So the motion in a circle with a constant speed is an example of accelerated motion. Understand, Harish? In exercise, one question came. You asked me. Have you remembered? Without changing the speed, acceleration keep on changes. The example is body is in moving in circular motion. Have you noticed it now? Are you clear? Even though speed is remains constant, but velocities keep on changes at every point of circular track. When the velocities keep on changes, as we know, rate of change of velocity, what we used to call? Acceleration. So if velocities keep on changes, then who will change? Ready? Acceleration also keep on changes. So that is why we can say if any body is in circular track, understand, we can say body is in constant speed, but it is an example of what? Example of accelerating motion. Understanding, everyone? So that is what, if they will ask you an exam, give the example of a body which is in constant speed but acceleration motion. But which we are accelerated motion? It is the body is in circular track. We can say a body is in constant speed but in accelerating motion. Is it okay, everybody? Danishkar? Yes, please. That is what you have to remember. Now you tell me, is it any force is needed to produce the circular motion? Anyone? Is it any force is needed to produce the circular motion? How the body will revolve continuously in the circular motion? Anyone? If the body is revolving, suppose this is the sun, suppose sun, earth is revolving around the sun. How it is running? Is it simply, or else somebody is exerting the force? You have to tell me. If you want to make the body to move in a circular path, either force is needed or not. That is what my question. Yes, please. If you want to make the body to move in a circular path, do you want to apply the energy or not? That is what my question.
Yes, sir.
You need force. Suppose it will take Earth. Earth is revolving around the sun. Why? Our sun is exerting some invisible force between the Earth and the sun. So that force only we used to call it as gravitational force. Understanding? So because of this gravitational force only, the Earth is always revolving around the sun. Is it yes or no? Same way. You all people know. For example, let me imagine this is Danishka. Now Danishka tied some stone and he is making the body to revolve in a circular path surrounding by him. So now, if he wants to make this body revolving in the circle path, either he need to apply the force or not continuously. Please respond. If he wants to rotate this body surrounding by him, either he need to apply the force or not. That is what I am asking. Yes, please respond.
Yes, sir.
Now, for example, Danishkar stopped applying force at this party, at this side, at this position. Then what will happen? Body will travel in this direction. Now, Danishkar stopped applying force in this particular position. Then body will go in this direction. Danishkar stopped applying the force in this direction. Then body will go in this direction. Yes or no, guys? Yes, please. Continuously you are revolving and you will release. It will go or not? Please respond. Yes. So now, if he wants to make the body to revolve continuously in a circular path, either the force is needed or not. That is what my question. If you want to make the body to move in a circular path, is it the force is needed? Yes?
Yes, sir.
Yeah, the force is needed. If you want to move the object, any object, then it needs some force to make it in a circular path. That force only we used to call as centripetal force. What we used to call, guys? Centripetal force. So because of that centripetal force only, the earth is revolving around the sun and other planets also revolving around the sun. So always if you want to move any object, understand in a circular path, then some force is exerting on the body to make the body to move in a constant speed in a circular path. So that force only we used to call it as centripetal force. What we used to call, guys? What we used to call? Centripetal force. Now, for example, you might be visited any kind of playgrounds or somewhere you can see. You might be see the merry-go-round. Have you noticed this merry-go-round in park and all? Yes, sir. Merry-go-round. Kids and all will rotate on this. Yes or no? Now, if this body wants to rotate continuously, then somebody should exert the force. Somewhere it will exert the force. Anybody can tell me? Middle will be the motor. Yes or no, guys? Yes, please respond. So middle will be the motor. So this motor will keep on rotating so that this full body will keep on rotating. So that is what. So the force exerted, if I want to make this body to revolve around this circular path continuously, then some force is exerted from the center. So that center, the force is exerting only will make the body to move in a circular continuous path. That force only we used to call it as centripetal force. What we used to call, guys? Centripetal force. Please remember, note it down. Right. The force which is needed to make an object, traveling in a circular path, the force which is needed to make an object, the force which is needed to make an object to move in which path, guys? Make an object travel in a circular path, travel in a circular path is called as what? Is called centripetal force. Please note it down. Centripetal force. So, in case of planets moving around the sun, understanding, and any object moving around some other object, then definitely the centripetal force is acting. That force only will take the force acting between the planets and the sun. What is the name of that force called as? Just now I said. What is the name of that force called as? Gravitational force.
Gravity.
Others will never open the mouth also. So that force only we used to call as gravitational force, which is exerting between the sun and the planets. So that force only we can say. What is that force called as? Centripetal force. So centripetal force is the force of gravity. So that is why gravitational force only holding this full solar system, which is rotating or revolving around the sun. So this is what even the satellites are revolving around the earth. If I'll take for example, moon is revolving around the earth and other artificial satellites are revolving around the earth. This is all because of which force, guys? Because of which force? Centripetal force. Do you understand? So everyone, so if you take for example athletes when they are in running track, so running track will be in a circular path, yes or no? So then also they may be maintain the constant speed, but they are in accelerating motion or non-accelerating motion. They are in accelerating motion. So even though the speed is constant, so because of the direction is continuously changing, if the direction is changing, who will change, guys? Velocity will change. If the velocity changes, who will change? Velocity changes, who will change? Automatically, acceleration will change. That is what you have to remember it. So that is what is uniform circular motion and as well as how the circular motion of a body is taking place. Is it okay, guys? Yes. So if you want to make the body to rotate in a circular track, do you need to apply the force or not? That is what my question. Danishkar, if you want to make the body to move in a circular path, do you need to apply the force or not?
Sir, we need to apply force, sir.
Yes. So without applying force, the body is not possible to rotate or revolve in a circular track. That is what you have to remember. Now, as I said, when the body is in uniform circular motion, so then, sir, how to calculate the speed? So what is the formula and what is the things, what is the distance, what is the displacement? That is all we'll study now. Shall we start, everybody? So please, all of you keep heading. Calculate the speed of a body in uniform circular motion. Calculate the speed of a body. Calculate the speed of a body. Calculate the speed of a body in uniform circular motion. Circular motion. Is it clear, everyone? So uniform circular motion means body is in which path, guys? Circular path. Is it yes or no? So that is what you have to understand first. So now let us see how to calculate this one. So if we'll take this is the circle, then every circle will be having center. What is that center called as? Mathematics. Center. We should represent with the what? C. Is it yes or no? Yeah, C, center. Understand? Now, if we'll connect that this corner to that corner, then we used to call it as something. What is that called as? If a line passing through the center, then it's called as what?
Diameter.
Diameter we used to say. Yes or no? Now, half of the diameter, what we used to call? Yes, please. Half of the diameter. Half of the diameter, what we used to call, guys?
Radius, sir.
Radius. Others don't know. That is what we are studying, correct? So that is what we used to call as diameter, and this is what we used to call as radius. Now let us take anywhere. Now, for example, so as I know, so the person is starting from here. So how to find the speed of a body? Let us understand. So now let me take here. This is what Reddy is turning here, point A, and this is what the point B. So this is what the center of curvature, sorry, C center we can say. Now if you want to find the speed, what is the formula of speed, guys? Anybody? Basic general formula of speed. Speed is equals to what? By time. Do you understand, everyone? Distance by time. But here, if the body is in straight line, we can calculate the distance. We can say this is the distance, understanding, and this is the time period we can take, and we will find the speed. Now, when the body is in circular motion, is it possible to measure the distance by using ruler? Is it possible to measure the distance by ruler? No. So that is why by the time we need to know something. That is what we used to call as. What is that, guys? What is that? Circumference of a circle. So what is the circumference of a circle formula? Circumference of a circle formula. Please. Yes, please. Circumference of a circle. What is the formula? Everyone. So this is the radius we can say, and this is what R plus R plus R, which is equals to what? Diameter. Understand, everyone? So R plus R, which is equals to 2R. So 2R is equals to what, guys? Diameter. Is it okay, everyone? So that is what you can represent with a small r also, no problem. All are same only. Okay. So that is what. Now, if you take the speed in circular body, circular motion, then speed of a body is equals to, understanding, circumference of a circle. Circumference of a circle divided by time period. Okay. What is the circumference of a circle formula? Anybody? Circumference of a circular path, the circumference of the circular, what is that? You studied in mathematics. Circumference of a circle. Circumference of a circle is 2 pi r. Understand? You all people don't know that also. Then how you are coming to 9th class here? So circumference of a circle is 2 pi r. So the time period is t. So speed of a body, if you want to calculate the speed of a body in circular path, then what is the formula, guys? What is the formula? 2 pi r by t. Understand? So 2 pi r, which will give you distance traveled by a body. What is that? Distance traveled by a body. In which motion? In circular path. Understanding? So circular path, the distance traveled by a body will be given by 2 pi r. So 2 pi r by t we can say. Or else, as we all know, r is equal 2r is equals to what, guys? Diameter d, and d is equals to what? 2r is equals to d. Now r is equals to d by 2. Is it yes or no, guys? Please respond. Everyone.
Yes, sir.
Radius and diameter. So radius is equals to 2 times of diameter divided by 2. That is what you have to remember. So in place of r, can I write the d by 2? Is it right or wrong? Yes, please.
Yes, sir.
That is what. So if we'll write that, then 2 pi r means in the sense of what? D by 2 by t, which is equals to 2 pi d divided by 2t. So 2t will get cancelled. What is the formula? Pi d divided by t. Okay, that is also the formula of speed of a body. So speed of a body, we are having two formulas. One is what? 2 pi r by t, or else pi d by t. Okay, guys. Now pi d means what, guys? Pi d also what? Pi d also distance traveled by a body. Is it okay, guys?
Yes, sir.
Yes, everyone. So that is what you have to remember. So now this is what about the speed. Now let us comes to the velocity. So as we know, velocity, what is happening, guys? Velocity keep on changes. Understanding, as direction is keep on changes. So velocity is keep on changes. No uniform velocity. Understanding, everyone? No uniform velocity for this body. So velocities keep on changes. So that is why we can say the body which is in circular motion is always what? Accelerated body. Do you understand, everyone? Yes, please respond. So we can say body is in acceleration continuously. Now, as we know, if you want to find the distance, what is the formula, guys? Distance in a circular motion. Distance in circular motion, please respond. Circular motion or circular path, distance is equals to what is the formula? Everybody, 2 pi r.
2 pi r.
Or we can say pi d. Understand? So this is the formulas we can use. Now, what about the displacement? Anybody can tell me what is the displacement formula here? Displacement is equals to, remember, keep it in mind always, when the body is traveling in a circular path, if body will stop at B point, if the body will start at, where it will start? If the body will stop at B point, like half rotation, then displacement is equals to half rotation. Number, half rotation. Okay, so every half rotation, 1.5 rotation, 2.5 rotation, 3.5, 4.5, 5.5, like half rotation will come. Displacement is equals to diameter. Understand, everyone? Diameter of the circular track. Is it okay, everyone? Whatever it is, 1,000.5 round also, diameter is equals to circular track only, displacement. That's all. Now, but if you take remaining cases, if it is make complete round, what about the displacement? Half rotation, okay. Complete rotation, what is the displacement? Anybody? So complete rotation means body will come to A point. Directly started from A, and after making full round again he came to A. So initial point and final point is same. Then what about the displacement?
Zero.
Initial point which is equals to final point, then we can say which is equals to what, guys? The displacement is 0. Is it okay, ready? Arun, Kailash? Clear, everybody? So
Yes.
I will ask you, if it is make 3 rounds, what is the displacement? 3 rounds, what is the displacement? 3 rounds completed, what is the displacement, I am asking?
0, sir.
0. Understanding?
0.
Displacement is 0. But what about the distance? What about the distance? Displacement is 0. What about the distance, I am asking?
Sir, 3 into 2 pi r, sir.
3 times of 2 pi r. Do you understanding? 3 times of 2 pi r. Understand? Now, what is the distance when it is make 3.5 rotation? 3.5 rotation. 3.5 rotation, what is the distance? Distance is equals to, what is that? 3.5 times of 2 pi r. Is it yes or no?
2 pi r.
But what about the displacement? If it is half rotation, displacement is equals to Half rotation, displacement.
Diameter.
Yes, please. Displacement is equal to what?
Diameter.
Diameter. That's all. Nothing will be there. Is it okay? Danishkar, Arun Kailash, Vartani. This is what, how to find distance and as well as displacement in circular motion. So whenever the body is traveling in circular path, speed remains constant, uniform speed or constant speed, but velocity is not constant. Velocities keep on changes, so that we can say body, when it is in circular motion, we can say it is always accelerated body. Is it okay, guys? Yes or no? That is what you have to remember. So this is what till here. Please, all of you do it fast. Any doubt, ask me. Make it fast. Everything you have to know. Later, sir, I don't know, sir. You are not supposed to say.
And also some cases we had.
Yes, please. Ready? Yes.
In some cases we have to use Pythagoras theorem, no sir?
That is a different case. That is a path based upon the triangular path. We have to use the Pythagoras theorem. Here, no use. Okay. Understand? For example, Hari, I will say, ready? Who asked this? Hari sir, ready? Now.
Ready, sir.
Okay, ready. For example, see, when you are traveling in a square path, is it okay, everybody? Look into the board now, look into the screen. This is the A point, this is the B point, this is the C point, this is the D point. Now, Reddy traveled from A to B, B to C, C to D, and as well as A to D. Now, finally he reached to the A point. What is the distance? Finally, he started from A point and reached to the A point. What is the distance, please, all of you? Distance is equal to square, guys. What is the distance? Square. Square,
Side
what is
square.
perimeter? Total perimeter. Perimeter of a square. So the distance traveled by a body is equals to perimeter of a square. Do you understand, everyone? Perimeter of a square. What is the perimeter of a square? A, each side A. So totally if you add, what will come? 4 times of A. That is what the distance will give you. Is it okay? Ready? Now, if we'll take the displacement, do you understand it? If we'll take the displacement, then initial point and final point is same. He came here, started from here, came here. What is the displacement? Arun Kailash? Initial point and final point is same. Then what is the displacement? Yes, please respond. What is that?
0, sir. 0, sir.
Why? He reached again to the same point called as A point. That is what? Now, as Reddy said, Pythagoras theorem we have to use. So when we will use, I will say you. Look into the board, look into the screen now. Let me take my path. I have been taken square or rectangle. Doesn't matter now. So this is the point A. This is the point B. Understand? Sorry, point B and point C. And this is what? Point D. Can I say now, everybody? Now. Body is traveling into A, understanding body is traveling into the B. Finally, he stopped at the point C. Where he traveled, guys? Use respond me. He started from point A and finally he stopped at the point C. Is it okay, guys? No movement.
Yes, sir.
What is the distance, everybody? What is the distance? Check it. Let me take this side is A and this side is also A. Now, what is the distance? Distance traveled by a body, which is equals to what? A plus A, which is equals to 2A. Is it okay, guys?
Yes, sir.
That is what? If suppose if it is a rectangle, this is the length and this is the breadth, then what is the distance? Distance is equals to L plus B. Is it okay, guys? Yes? Understand? Now, what is the displacement? That is what my question. Let me see who will say. What is the displacement? The shortest distance between the initial and final point. Yes or no? Now, what is the shortest distance between initial and final point? Anybody? So directly if we'll join, then this diagonal. Yes or no? This diagonal is the shortest distance between them. Is it yes or no, guys? Kindly respond. Everyone. Now, in this case, now I want to find the displacement. So, as we know, it is looking like a triangle. Is it yes or no? Is it looks like a triangle or not?
Yes, sir.
Now, this is the base and this is the height and this is the what? Hypotenuse of the triangle. Understanding? So now, if you want to find by the time, then we have to apply what? Pythagoras theorem. So what is the Pythagoras theorem?
C square is equal to A square plus
A
B
square.
square.
B square is equals to A square plus B square. Do you understanding? That is what. So basically we can say, so here what is the C square? AC square. Understanding? So AC square is equals to, A means what? AB square plus BC square. Is it yes or no? So this is only we used to called as Pythagoras theorem. So this by applying theorem, we can find what? We can find the AC. Is it okay, guys? Shortest distance, yes or no? So in these cases, we have to use the Pythagoras theorem. That is what? Hypotenuse square is equals to adjacent square into understanding opposite square. That is what we have to remember. So you can write hypotenuse square is equals to opposite square understanding into adjacent square. That is what we used to call it as Pythagoras theorem or Pythagoras theorem, whatever it is. So this is what when we have to use, you understand. Do you understand, guys, when we have to use Pythagoras theorem? Yes. Now, for example, look into the board clearly. If the body will stop at point D, then what is the distance and what is the displacement? Anybody? If the body stopped at point D, started from point A and stopped at point D. Now, what is the distance and displacement? Let me see who will say. Boys, please.
Distance is same. Displacement.
Distance is same. Distance is how? Distance is what? This is A, this is A, and this is A. Then what is the distance?
3A, sir.
A plus A, which is equals to 3A. Now, what is the displacement?
A.
If this is A, then what is the displacement? A to D. This is the shortest distance. Yes or no? The shortest distance is what? Shortest distance is